Hey, this is Dr. B again, and let's take a look at infrared spectroscopy. Here's a simple infrared spectrometer here. The prices of these have gone down and the size of the instruments have gotten smaller, like just about all spectra devices over the years. And what these things basically do is they plot the infrared spectrum of a typically organic substance. They absorb richly in the infrared region, and they typically give a nice fingerprint that you can use to identify your substance. You can use the fingerprint technique. You think you know what it is. You look at the IR. It's a perfect match. You're done. Or if you don't know what it is, you can identify some of the functional groups that are present, and that's the main purpose of this lecture. Here's the absorption regions in the infrared region. They use this unusual term wave numbers, which is fine. It goes from 4,000 down to about 500. And here's the sorts of functional groups that you're going to see. Over on the left here, you see OH and NH stretches. If it's these typically are big blobs, so imagine a big curve there. If it's split in two, it typically means NH2. If it's not, it either means you have an NH or an OH, or it means you have water in your sample, which happens oh so often. So when you see a little one like that, or sometimes even a little bigger, typically ignore it because it's hard to get a purely dry sample. The next thing to look for is the aliphatic aromatic region, which is very diagnostic. If it's to the right of 3,000 wave numbers, that means aliphatic. That means it's not an aromatic substance. And when I think aromatic, I typically think benzene, a 6-numbered ring with alternating double bonds through it. But any of those contiguous cyclic alternating double bond substances are aromatic. If you don't see the absorption to the left of 3,000, you can rule that out. It's only aliphatic. Next thing is pretty rare, but the triple bond region does show up occasionally. You can get an alkyne or a nitrile, depending for here, and it's usually a pretty small, sharp peak. Those don't show up very often. On the other hand, the carbonyl region is perhaps the most single diagnostic region right here, and that's anything from about 1850 to 1650 wave numbers. It's typically the biggest peak in the whole spectra, and if you see an absorption there, you almost certainly have a carbonyl, C double bond O. Can you subdivide it? Yes, you can, and I really like, here, I want to go to it. I really like this graph that I found that pretty cleanly shows you what the typical absorptions are. If you look these up in other tables, there's so much overlap it's hard to figure out. And this can be a little misleading. Don't assume that this is exactly where they are, but it's a good place to start. I also love the idea that whoever came up with this focused on the number 1740 as a central region to the left of these and to the right are those. So let's try to recall what these are. Knowing your functional groups helps here. Acid chlorides, anhydrides, esters, aldehydes, ketones, carboxylic acids, and in this case, a secondary amide. So, handy stuff. Let's use it to identify 4 substances. I really wonder what this looks like to somebody seeing these for the first time. I wonder whether you're going like, "Wah!" But we can do this. There's 4 pure substances. There's their IR spectra. One's an alcohol, one's a carboxylic acid, one's an ester, one's a primary amide. Let's figure it out. I just work my way from left to right and think about what I can glean from these substances. I do want to point out that once you get beyond carbonyl groups, you're in kind of no man's land. Most professors will attempt to show you where a CO or a C double bond C bond might be in here, but I ignore this totally. I call this the fingerprint region because there can be so many false positives that it can get you in trouble. So let's just focus on a few main regions. Is that an OH? Hopefully you recall what I said, and probably not. That's just water. This looks like it's to the right. Oh, I think I have the numbers. Since it's all so small here, I think I threw in there you go, all the numbers for you. It's to the right of 3,000. It's aliphatic. It does have a carbonyl group, and if we really believe it, it's probably an ester. So let's go with that for that one. It is. There it is. How about this one? 3,300 broad, and it's not split in two. I think it's overlapping with something, but I think it's either an NH or an OH. And I'm looking at this, that means it could be this one, but this is NH2 and should be 2 peaks, so I'm already, it could be an alcohol, right? 2940, it's not aromatic, it's the right of 3,000. 1712, if If this is a pure substance, it's not an alcohol because that's a carbonyl group. What kind? Well, it's to the right of 1740. It could be any one of these. It's pretty well to the right of it. Right? But look at this. This is a substance which has an alcohol and a carbonyl. It's called a carboxylic acid. There's your alcohol. There's your carbonyl. That's a carboxylic acid. Okay, here we do have these big absorptions here, and we have two of them. If you have two peaks, it looks like NH2. I'm strongly thinking this is a primary amide, but that's not primary amine. That's amide. That means we're supposed to have a carbonyl group as well. 1662. It's on the edge, but it is above 1650. And look at that. That is a secondary amide. I don't know if I said primary before. Two NHs, right? Fine. It's aliphatic. It's that. Check out the rest of this if you think you have it. It should be a match for the fingerprint region. Boy, that looks like an alcohol, pure and simple, right? I suppose it could be amine, but hey, it's not even on our list here. It's aliphatic, and there's no carbonyl, so that's an alcohol. Okay, that's a little bit about identifying substances using infrared spectroscopy.